Hello, the Math Dog here. In this video I'm going to go through the greatest common factor, which I'm going to call the GCF, and the least common multiple, the LCM, of two or more different numbers. Now the greatest common factor is going to be very important in what we do later with factoring, and the least common multiple has many purposes. Maybe the primary one that you first encounter is when you add and subtract fractions, because you need to get a least common denominator, or you should try to get a least common denominator. It makes adding and subtracting fractions a lot easier. Well, the LCM is in fact the LCD, or least common denominator, of two fractions. So let's get started. So first of all, the integers. An integer is, or the integers are the numbers including the whole numbers and their opposites. So the whole numbers are 0, 1, 2, 3, etc., 4, up to infinity. And then the opposites of these numbers, which opposite of 0 is 0, opposite of 1 is -1, opposite of 2 is -2. So that's what an integer is. It is a positive or negative whole number. So 1/2 is not an integer. 0.1, which is 1/10, those are fractions, those are not integers. So for our work with the greatest common factor and least common multiple, we will only be working with integers. Alright, so let's start with the greatest common factor. An integer factor of a number is a whole number that divides into the number with no resulting remainder. So the integer factors of 12 are, since 12 divided by 1 is 1, that is a factor, integer factor. Since 12 divided by 2 is 6, that's an integer factor. Since 12 divided by 3 is 4, that's an integer factor. Since 12 divided by 4 is 3, that's an integer factor. And since 12 divided by 6 is 2, that is an integer factor. And 12 divided by 12 is 1. And the first one there, that's a mistake. 12 divided by 1 is 12, not 1. So listing the factors, that would be 1 in increasing order. That'd be 1, 2, 3, 4, 6, and 12. So those are the integer factors of 12. So now let's list the factors of 24. Well, we know that 1 divides into 24, goes in 24 times. Let's just pair them off right now. So 2 goes into 24 12 times, 3 goes into 24 8 times, 4 goes into 24 6 times, 5 doesn't go in, 6 goes in 4 times, we already covered that, 7 goes in, doesn't go in, 8 goes in 3 times, 9 doesn't go into 24, 10 doesn't go into 24 without a remainder, 11 doesn't, 12 does twice, and then we're at 24. So now the factors of 24 would be 1, 2, 3, 4, 6, 8, 12, and 24. Those are the integer factors of 24. So the greatest common factor of two numbers is the largest number that divides into both numbers with no remainder. So let's take 18 and 24. Well, 18, 2 goes into 18, well 1 goes in there, always will divide in there. 2 goes into both those numbers since they are, so 1 goes in. 2 goes in, because 2 goes in 18 9 times, 2 goes 24 12 times, 3 goes in. 3 goes 18 6 times, goes into 24 8 times. 4 does not go into 18 evenly. 5 goes into both. 6 goes into 18 3 times, goes into 24 4 times. 7 goes into, does not go into either. 8 does not go into either. 9 goes into 18 but not 24. 10 doesn't go in either. 11 doesn't. 12 doesn't. So basically we're down to 6. So the greatest common factor of 18 and 24 is 6. So notice 6 goes into 18 again. 3 times, no remainder, remainder 0. And 6 goes into 24 4 times with no remainder. Now a little more methodical way to do that would be to list the factors of 18 and 24 and see the largest one they have in common. So factors of 18 are 1, 2, 3, 6, 9, and 18. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. So you look at the list and you see the largest factor they have in common is 6. So that is the greatest common factor. Okay, suppose we had an example where we had 3 numbers. So you kind of can look at this probably and figure out that, well, that's got to be 5. But let's look at the greatest common factors of 10 by listing its let's list the factors of 10, 15, and 25. So factors of 10 are 1, 2, 5, and 10. Factors of 15 are 1, 3, 5, 15. And the factors of 25 are 1, 5, and 25. So you see the largest number that they have in common as a factor is 5, and that's the greatest common factor. Okay, so the GCF, or greatest common factor, is 5. Alright, so now we use the greatest common factor when we reduce fractions. So there's different ways to reduce fractions, but you're looking for numbers that divide evenly into the numerator and denominator. So, I mean, 2 is a common factor of 18 and 24, which would reduce it to 9/12. But that's not the least common factor, because notice then we can divide 3 into both 9 and 12, which gives me 3/4. So notice that, again, if we listed the factors of 18 and 24, which we've done before, I'll do it again. That for 18, that's 1, 2, 3, and then we have 6, goes in 3 times, 9, 18, and then 24, again, is 1, 2, 3, 4, 6, 8, 12, 24. The greatest common factor is 6. So we could have reduced it in one step. You can do it in multiple steps like I did here, but the greatest common factor is 6, and we get 3, that should be a 6 there, we get 3/4. So remember, when we're dividing by, we can divide by, we're dividing by 2 over 2, dividing here by 6 over 6, so it's not changing the value of the fraction, it's just dividing it into, so here initially the units are 24ths. When we're done, we've broken the units down to fourths. Okay, suppose you have 6 red marbles, 9 yellow marbles, and 12 blue marbles. If you want to package the marbles in identical packages, how many packages can you make? What is in each package? So this is a problem where actually we can use a greatest common factor. So let's list the factors of 6. That would be 1, 2, 3, 6. Then that would be for red marbles. Then for yellow marbles, we have 9 of them. That's 1, 3, 9. Those are the factors of integer factors of 9. And then we have blue, which is 12, which the factors are 1, 2, 3, 4, 6, and 12. So looking at this, you can see the largest number divides into all those and is the first factor in common, or the largest factor in common is 3. So my answer here is 3 packages. I can make 3 packages, and then what's going to be in each package? Well, I have 6 reds. 6 divided by 3 is 2, so I'm going to have 2 red in each package. Then 9 divided by 3 is 3, so I have 3 yellow marbles in each package. And then 12 divided by 3 is 4, so I have 4 blue in each package. So I have total of, notice, 27 marbles. 6 plus 9 plus 12 makes 27. Each package is going to have 9 marbles in it. So a package is going to have 2 red, 3 yellow, and 4 blue. Okay. So now let's look at the least common multiple. So the greatest common factor was the largest, can be thought of as the largest, is going to be the largest factor that they share in common. Okay. Least common multiple of two numbers is the first integer multiple that is the same for both numbers. And it is also the smallest number that both numbers divide into with no remainder. So the least common multiple of 6 and 9. Well, okay. So let's list the multiples of 6 first. So this is multiples now. We're using integer multiples. So the multiples of 6 are 6, 12, 18. So 6 times 1 is 12. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. Times 4 is 24. Times 5 is 30. So that's 6. Okay, so then 9. Multiples of 9 are 9, 18, 9 times, that's 9 times 2, 9 times 3 is 27, 9 times 4 is 36. Okay, so what we're looking for is the smallest number both numbers divide into with no remainder, and that would be 18. So that is the least common multiple of 6 and 9. It's also the smallest number that they all both divide into evenly. 9 goes into 18 twice, 6 goes 18 3 times. So let's do one now with 6, 10, and 15. So multiples of 6 are 6, 12, 18, 24, 30, 36, 42, that's 6 times 7, 6 times 8 is 48. Okay, so 10 multiples of 10 are 10, 20, 30, 40, these go on, etc. 15, multiples of 15 are 15, 30, 45. Well, the smallest number they all divide into and the first multiple they have in common is 30. So least common multiple, or LCM, of 6, 10, and 15 is 30. We use the least common multiple when we add or subtract fractions that have unequal denominators, which is the bottom of the fraction. Okay, we can also use least common multiple to determine which fraction is larger. So what we do is we have 3/4 and 4/5. So the multiples of, we take the multiples of each, or the smallest number they both divide in evenly. Well, multiples of 4 are 4, 8, 12, 16, 20, 24. Multiples of 5 are 5, 10, 15, 20, 25. So the smallest number they divide in evenly and the first multiple they have in common is 20. So that is going to be our new denominator. So 3/4, we need to get the units of the fractions the same, and we're going to use 20. So our least common denominator, which is the least common multiple, is going to be 20. So to make an equivalent fraction, 4 times 5 is 20, so then I have to take the numerator by 5 also, so that's 15/20. So 3/4 is equivalent to 15/20. Okay, then 4/5, I have a new denominator 20. 5 times 4 is 20, so I take 4 times 4, which is 16. So 4/5 is 16. Since 16/20 is larger than 15/20, 4/5 is greater than 3/4. So as I mentioned earlier, you use the least common multiple to add fractions with different size denominators. You cannot just go, this is a common mistake beginner students make. They say this is 8/10. You can't do that because you need to have your units the same size for both denominators. So what I'm going to do here is I'm going to get the least common multiple, which is the same as the least common denominator of 4 and 6. So we could list them. The multiples of 4 are 4, 8, 12, 16, 20, etc. Multiples of 6 are 6, 12, 18, etc. So notice the least common multiple is 12. So the advantage of using the least common multiple when you add or subtract fractions is you don't have to do as much reducing later. So in this problem, what I'm going to do is I'm going to say, okay, 3/4, well, my least common multiple or denominator has got to be 12. So what do I need to multiply 4 by to get 12? I need to multiply it by 3, so I need to multiply by 3 over 3, and remember 3 over 3 is just 1, so we're not changing the value of the fraction. So then for 5/6, to get 12 out of 6, I need to multiply by 2, so I multiply the top and bottom, the numerator and denominator, by 2, which is 2 over 2, which is equivalent to 1, so it's not changing the actual value or size of the fraction. So 3 times 3 is 9, 4 times 3 is 12, then we have 5 times 2 is 10, 6 times 2 is 12, so now we have our common denominator 12, so we get 19 over 12, which is, we call that an improper fraction, because the numerator is larger than the denominator. And actually there's nothing wrong with improper fractions, but often you'll want your answer as a mixed number. Now notice that cannot be reduced to anything because the only common factors of 19 and 12 are 1. So to make it a mixed number, we divide the denominator into the numerator. 12 goes into 19 once. 1 times 12 is 12. Subtract, that's 7. So the mixed number is 1. That's your whole number of times. And the fraction is 7 over 12. Again, you could have used 24 as your least common denominator here. Not your least common denominator, but your common denominator. But you would have had to reduce it. So notice if I did that, that would be 6 over 6 here for 4. Then 5 over 6 I need to multiply by 4 over 4, which gives me 18 plus 20 over 24, which is 38 over 24. But that's not in lowest terms because I know at least 2 divides into both those. So I have to reduce again to get in lowest terms. That's 19 over 12, which is what I got before. So by using the least common denominator, which is the least common multiple, you save some steps when you have to reduce. Okay, last thing here. Suppose on a 1 mile running track, Tom can complete 1 lap in 6 minutes. Ryan can complete 1 lap in 8 minutes. If they start together, after how many minutes will they first cross the start-finish line together? So we got a 1 mile running track, okay? So here's the start-finish line. Okay, so Tom is 1 lap in 6 minutes. Ryan is 1 lap in 8 minutes. So we can actually use the least common multiple to answer this question. So for Tom, he completes laps after 6 minutes, 12 minutes, 18 minutes, 24 minutes. These are all multiples of 6, 30 minutes, 36 minutes. Ryan completes laps after 8 minutes, 16 minutes, 24 minutes, and then that would be 32 minutes. So notice 24 is the least common multiple. So after 24 minutes, they will cross the start-finish line together. So notice Tom has done 4 laps and Ryan has done 3. So we're going to look at one last thing in this video, and it is using what we call prime factorization to find the least common multiple and greatest common factor. So You usually don't have to use this method because you can figure it out in your head or on a quick sketch on a piece of paper, jotting some stuff down. So remember, to find the greatest common factor, probably the easiest way is to figure out the largest number. It divides into both all the numbers you're trying to find the greatest common factor of evenly with no remainder. And the least common multiple is the first multiple of the numbers you're looking at. So it's the smallest number that all the numbers divide into evenly with no remainder. So to do this, we need to use prime numbers. A prime number is a number that is only divisible by itself and 1. So we don't consider 1 a prime number. So let's list the prime numbers up to 40. The first one is 2 because 2 only has 1 and 2 as its factors. And 3, 4 is not prime because the factors are 1, 2, and 4. That's 3 factors. Then we have 5 because the only factors of 5 are 5 and 1. 7 is a prime number. 6 is not because the factors of 6 are 1, 2, 3, 6. 7 is because 1 times 7 is 7. There are no other integer factors. 8 is not because the factors are 1, 2, 4, and 8. 9 is not because the factors are 1, 3, and 9. 10 is not because the factors are 1, 2, 5, 10. So next one is 11. 12 is not because any even number can't be prime because 2 is a factor. 13 is prime. 14 is not because, again, 2 is a factor, so 1, 2, 7, 14 are the factors. 15 is not because you have 1, 3, 5, and 15. 16 is not because it's an even number, again, and you have the factors 1, 2, 4, 8, 16. 17 is, 18 is not, it's even. 19 is a prime number, the only factors are 1 and 19. 20 is not, it's even. 21 is not, 1, 3, 7, 21. 22 is not, it's even. 23 is a prime number because the only factors are 1 and 23. 24 is not, it's even. 25 is not, 1, 5, and 25 are the factors of 25. 26 is not, it's even. 27 is not, 1, 3, 9, and 27. 28 is not, it's even. 29 is a prime number. The only factors are 1 and 29. 30 is not, it's even. 31 is a prime number. The only factors are 1 and 31. 32 is even, it's not. 33 is not, 1, 3, 11, and 33. 34 is not, it's even. 35 is not. The factors are 1, 5, 7, and 35. 36 is not, it's even. But 37 is a prime number. The only factors are 1 and 37. 38 is not, it's even. 39 is not because the factors of 39 are 1, 3, 13, and 39, and 40 is not, it's even. So these are your prime numbers up to 40. So let's demonstrate how you do a prime factorization. So let's say I want to do a prime factorization of 16 and 24, then find the greatest common factor and least common multiple. So 16, what we do is we start by breaking it up into something. You could do 2 times 8 or you could do 4 times 4. You make a little factor tree. Call this a factor tree. Well, 4 is not prime, but I can break it up into primes. That's 2 times 2. 4 is also, again, 2 times 2. Well, the only factor here is 2, and instead of writing it 2 times 2 times 2, 2 times 2 times 2 times 2, I'm going to write it as 2 to the 4th power. Then 24, I do a similar process. I could break it up many ways. I could go 3 times 8, I could go 4 times 6, it doesn't matter. You're going to end up with the same thing. So let's use 4 times 6. Well, 4 is 2 times 2. 6 is 2 times 3. So a prime factorization, these are all prime numbers now, that's why it's called a prime factorization. Instead of writing 2 times 2 times 2, I can write 2 to the 3rd times 3. So the greatest common factor is going to be, as we kind of can look at this, we know it's going to be 8. But what we do is we first look for a common factor. The common factor here is 2. 3 is not a factor in 16. And then we take the highest power they have in common, which is 2 to the 3rd. And 2 to the 3rd is 2 times 2 times 2, which is 8. So for this problem, this is overkill, but for some harder problems, it's not. So then the least common multiple what we do is we take the highest power of all the factors that appear, and the factors that appear are 2 and 3. Well, the highest power of 2 is 2 to the 4th. The highest power of 3 is 3, or 3 to the 1st. Well, 2 to the 4th is 2 times 2 times 2 times 2. That's 16 times 3, which is 48. So the least common multiple of 16 and 24 is 48. You probably could figure that out because 16 goes to 48 3 times, 24 goes to 48 twice. So let's do one final example, a little more challenging. So this may show you why prime factorization can be sometimes useful. So we have 20, which is, say, 4 times 5. It's also 2 times 10. 4 is 2 times 2 times 5. So this I'm going to write as 2 to the 2nd times 5. Okay, that's a prime factorization because 2 and 5 are prime numbers. 4 and 4 is not a prime. So 24 then, again, I think I did 4 times 6 last time. I'm going to do 3 times 8 to show you get the same thing in the end. Bring down to 3. 8 is 2 times 2 times 2. So this is then can be written as 2 to the 3rd times 3. And then 56 is 7 times 8. 7's a prime. 8 can be written again as 2 times 2 times 2. Bring down to 7. So this is 2 to the 3rd times 7. So now we can figure out the greatest common factor, which is the largest power. So notice they do not share 3, 5, and 7, so that's not going to be part of the greatest common factor. We take the highest power of 2 that they share in common, which is 2 to the 2nd. So the greatest common factor of these numbers is only 4. Notice that 14 times 4 is 56. And then we have 6 times 4 is 24, and 5 times 4 is 20. So now the least common multiple is going to be the highest power of each factor that appears. So the highest power of 2 that appears is 2 to the 3rd. The highest power of 3 is just 3 to the 1st, or 3. We have a 5 to the 1st, so we have 7. So this one's going to be a little bigger, much bigger than what we've been using or figuring out. So 2 to the 3rd is not 6. Please remember it's not 6. This is repeated multiplication. That's 8. So this is 8 times 3 times 5 times 7. So probably what I'm going to do here is I'm going to go, you can, again, the order that you multiply is not important. I'm going to say that's 24 times 5 by 7. I'm going to take 24 times 5 over here. That's 120. So this gives me 120 times 7. So actually mentally in your head you should be able to do this. 12 times 7 is 84. Add a 0. So that's going to be 840. So again, if you want to multiply it out, I'm just going to demonstrate. That's 0. That's 14, carry a 1. That's 840. So the least common mole is 840. That's pretty hard to see just looking at. So this is an example. Hopefully you can see why a prime factorization can be useful when you get some numbers that are, particularly when they get larger. All right, let's do some practice problems. So first, find the greatest common factor and least common multiple of the numbers 6, 12, and 15. Stop the video. After I get done talking here, then do the problem, restart it when you have the answer. I only expect you to use one method. I will go through several methods to answer this question. Okay, so let's do the greatest common factor first. So I guess what I would do if you couldn't see anything, list the factors of 6 first. So 6 has factors 1, 2, 3, and 6. 12 has factors of 1, 2, 3, 4, 6, and 12. And then 15 has factors of 1, 3, 5, and 15. Okay, so the greatest factor that they have in common, you can see, is 3. And so that's the greatest common factor. Okay. You can also mentally think about, well, what's the largest number that divides into all these numbers? And that would be 3, which is essentially what we did here, except you're doing it mentally. So the long way to do the least common multiple is to literally list all the multiples of all these numbers. So the least common multiple of 6, let's list the multiples of 6, so start with 6. You've got 6, 12, 18, 24, 30, 36, 42, 48, 6 times 9 is 54, then 60, etc. 12, got 12, 24, 36, 48, and 60, so there's a possibility there. And then 15 is 15, 30, 45, and 60. So the least common multiple of these three numbers is going to be 60. So the LCM is 60. So this is easy to see what you're doing. You're just grinding out the multiples, and the first one they have in common is what it's going to be. You can also mentally though go what's the smallest number all three of these divide into, and at first you might be thinking 30, but then you realize 12 doesn't go to 30, so it has to be 60. So now I'm going to show the prime factorization method, which may be overkill for this question, but for some questions it works. So we break everything into its prime factors. So 6 is going to be just 2 to the first times 3 to the first. 12, you can start with 4 times 3, you can do 2 times 6, but that's going to be 2 times 2 times 3, which is 2 to the second times 3. So we have 2 to the second times 3 for 12, we have 2 times 3 for 6, and then for 15, that's 3 times 5. Okay, I'm using this practice problem to show the prime factorization, but you can do any method you want. So find the greatest common factor, least common multiple of 27 and 81. Stop the video, then give it a shot, and then turn on and see if you did what I did. Okay, so 27. Let's list the fact. Let's first do the greatest common factor. So 27 factors are 1, 3, 9, 27. Factors 81 are 1, 3, 9 times 9, and then you have 27 times 3, and then 81 times 1. So the greatest common factor is 27. For least common multiple, you could just grind it out. 27 is going to be 27, 54, 81. 81 is just going to be 81. There's your least common multiple. So the greatest common factor is 27, least common multiple is 81. Well, let's do a prime factorization here. So 27 is 9 times 3, but that's 3 times 3 times 3, so 3 to the third is the prime factorization of 27. Then 81, 9 times 9, that's 3 times 3 times 3 times 3, which is 3 to the fourth. So they share 3 to the third in common, so the greatest common factor is 3 to the third, which is 27, and the least common multiple is the highest power of each factor that occurs, and that's 3 to the fourth, which is 81. So that's how that works. So in this problem, I'm going to strictly use a prime factorization to answer the question. So I'm going to break down 16 into its prime factors. So one thing we know is 16 is 4 times 4, but 4 is 2 times 2. 2 is a prime number. Remember, prime number is a number that only 1 and itself are factors of. So 16 is 2 to the fourth, okay? 24 then, you can start out 6 times 4, 4 times 6, 8 times 3, 2 times 12. I'm going to do 4 times 6. So 4 is 2 times 2, and 6 is 2 times 3. So the prime factorization of 24 is 2 to the third times 3. And then 27 is 9 times 3, but 9 is 3 times 3, then times 3, so 3 to the third. So we have 2 to the fourth, 2 to the third times 3, and 3 to the third. So remember, the greatest common factor is going to be the highest power of each factor they have in common. So actually, you notice that there is no greatest common factor other than 1, because they don't share a 2 and they don't share a 3, so it's just 1. Okay? 2 doesn't go into 27, it's an odd number. Now, least common multiple is the highest power of each factor that occurs. Okay, well 2 occurs to the 4th power and 3 occurs to the 3rd power. So putting that back together, that's 16 times 27. Okay. So that's 42, carry a 4, 1 times 7, 7 plus 4 is 11. Add a placeholder 0, 6 times 2 is 12, carry a 1, 1 times 2 is 2, plus 1 is 3. So we get 432 as our least common multiple. That would be a hard number to find using just the start listing the factors method. That would be take quite a bit of paper and time. Okay, so there's our answers there. So here's our last practice question for this video. So after I get done reading, stop the video, do the problem, and see if we agree. So a man plays golf every 3 days and tennis every 4 days. If today is the first day in May, May 1st, and he plays his first round of golf on May 3rd, how many times the next month does he play golf and tennis on the same day? Okay, stop the video, work the problem, see if we agree. Okay, so this is a least common multiple question. So when's the first day they play golf on the same day? Well, the smallest number 3 and 4 goes into is 12. Okay, so that would be May 12th. I'll put 5/12 as the first day. Then the second time would be 12 days later, which would be 5/24. Okay, 12 days later then puts us over 31 days because May has 31 days, so it's going to be twice. Okay, on the 12th and the 24th, they will play golf and tennis on, or he will play golf and tennis on the same day. So this is it. I hope this was helpful in trying to express the difference or demonstrate the difference between greatest common factor and least common multiple. If you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.